Good morning, everybody. Today we are going to continue from our previous video where we have learned how to use new type of functions that are inverse trigonometric functions, that is sine inverse, cos inverse and tan inverse, because of which is the inverse of sine, cos and tan. What are their inverses? Sine inverse, cos inverse and tan inverse. These are specially used to find the angles. This majority of the times the sides. So let's proceed with it. This was a problem which we were discussing. Let's continue with that. So we have this triangle LMN and the angle L is not given. I'm sorry, it's 65 degrees. MN is given, then LM is given. So we have to find what is angle L. So associated with angle L, we know what is the opposite side. Then we know what is the adjacent side. We have no information about the hypotenuse. This will be our hypotenuse. Okay. But we are not asked to find that, so let it be there. Next, we have to find L. So what is the equation, sine equation dealing with opposite by adjacent? That will be tan. So what is given? It is tan L is given. So now we have to find L. So this is done by using the inverse operator. We are going to bring tan to the right hand side. So what remains on the left hand side will be only angle L. Okay, what comes to the right hand side will be tan. Tan will become tan inverse. Okay, then whatever is remaining here, that we have to write opposite by hypotenuse. Okay, so let me erase this part and proceed. Now let us substitute. What is tan inverse? What is the opposite side? Opposite side is 35. Adjacent side is 65. If we use a calculator, we had to find tan inverse. So tan inverse is what was that? 35 divided by 65 will give us 28.3. So that will be our answer. That is 28 point. We can write up to 100th place value. This is our angle L. So you have seen how to use tan inverse. I'll show you the calculator once again. We can find in calculator sine, cos and tan, and as well as sine inverse, cos inverse and tan inverse. Maybe you have to press a shift or something. This I'm using Google calculator. So this is how we find the inverse. Press the tan inverse, a bracket will appear. Inside the bracket you can write 35 and the normal division sign, then the 65, then if you give equal to or something, answer will be 28.3. Okay, next, coming to our another problem. I'm sure you'll be having a lot of confusion right now, but it will become less confused when we solve more and more problems. So our second question here, what is given is triangle KIP is given and we have to find angle I. This is our question. So how do we proceed with this? It will be now respective to angle I, what do we know? What is given with respect to angle I? It is opposite is given. Let us decide which trigonometric function to use later. Okay, opposite. Then what respect to I, what is given? It is not the adjacent, it is the opposite to right 90 degree, that will be hypotenuse. So opposite by hypotenuse, which sine function is associated with opposite and hypotenuse? So, uh, so it is sine, opposite and hypotenuse. So we have to find sine of angle L. This is our question. So we have to bring the sine to the right hand side. That will become angle I is equal to sine inverse of opposite by hypotenuse. Then sine inverse, what is the opposite here? It is 8 by hypotenuse is 10. Then sine inverse 8 by 10 is 0.8. 8 by 10 is 0.8. Go to the calculator, uh, clear everything, go to sine inverse and write 0.8. That will give you 53.13. So our degree which we are searching is 53.13 degrees. This is our angle I. You might be somewhat clear now how to find. Let me solve some more problems. Now this will be our third problem in finding the angles using inverse trigonometric functions. So here what is given is triangle DEF and we have to find angle E. With respect to angle E, what is given is opposite. Then what is given is hypotenuse given. No, that is not given. Hypotenuse is not given. So what is given is 6. That is adjacent to angle E. Adjacent. This is of course tan. We have to find tan of E. Then angle E is equal to, bring the tan to the right hand side. Tan inverse of opposite by adjacent, that is equal to tan inverse. What is the opposite side? Opposite side of angle E is 4. Then adjacent side is 6. That is equal to, we have to use the calculator right now. Clear all. Go to tan inverse function and 4 by 6. 4 divided by 6, that is 33.69. Always it's safe to take up to 100th value. That is two places after the decimal point is 100th, 10th, 100th. So it is better to take that way. So angle E we have found, that is 33.69. Let's go for our fourth problem. Here it is LYN in this triangle. We have to find Y. So y is our triangle, our angle which is to be found, and with respect to angle y, what is given is hypotenuse, and what is given is adjacent. Obviously, opposite side is not given, adjacent is given. So adjacent and hypotenuse, which is the equation which has these two sides? That will be cos. So we have to find cos of y. So adjacent will be, the side adjacent is 3 and the hypotenuse is 10. Then y, angle y is nothing but, bring the cos to the right hand side, that is cos inverse, of, so now cos inverse of 3 by 10, that is cos in, we are clear all. Go to the function cos inverse of, go to main, that is 3 divided by 10, that will give you 72.54. Go back to the answer, cos inverse of 3 by 10, that is equal to 72.54 degrees. In the calculator, students, you have to always keep in the degrees. There will be radians and degrees. We are calculating the angles in degrees. So always see that your calculator is pressed in degrees. Next, going to our last problem, fifth one. Okay, now we are going to find angle O. So how are we going to do that? This will be our initial aim. I'll color red. Everything for associated with angle O. So for angle O, we can see that what is given with respect to angle O, that is opposite and hypotenuse, isn't it? This is the hypotenuse. So we know opposite and hypotenuse, that will be sine of angle O, because sine is the one which deals with opposite by hypotenuse. So opposite is okay, we can write it as angle O is equal to, bringing the sine function to the right hand side, that will be sine inverse of opposite by hypotenuse, that is equal to sine inverse of what is opposite, 4 by 10, that is equal to, I'm sorry, it is 9. Okay, 4 by 9. Now we have to find sine inverse of 4 by 9. That is, go to calculator, sine inverse of 4 divided by 9. That is 26.39. Just round it off to 100th place, and our answer will be 26.39. This will be our angle O. Now to find angle Z, there are two ways after we find the angle O. To find angle Z, what we can do is, one way, find a trigonometric function associated with angle Z in which 4 and 9 is given. Or you can, the rule of the triangle, that if you add all the angles of the triangle, the sum is 180 degree, isn't it? So 180 degree is a sum. So we know one angle, that is angle E, is 90 degree. Then we know that one angle O is 26.39 degrees. Then we have to find angle Z. This is one way to find angle Z. That is, if we add 90 plus 26.9 and then subtract that answer from 180 degree, we are going to get the angle Z as 63.61 degrees. Or else, I'll give you one option, that is, we can even find using the trigonometric function. If you want to use the trigonometric identity, then you can use that way also. So for angle, okay, I'll use a different thing for, let me take LO, that will be for angle Z, that will be, um, angle Z is associated with, now we are finding angle Z associated with 4 will be adjacent side to it, okay, not the opposite anymore, and 9 will be hypotenuse. Hypotenuse will remain hypotenuse. So which is this trigonometric function dealing with adjacent and hypotenuse? That will be our cos, isn't it? So now angle Z is nothing but, bring the cos term to the right hand side, that will be cos inverse of adjacent by hypotenuse, that is equal to cos inverse of what is adjacent is 4 and hypotenuse is 9. So go back to the calculator, clear this up and find the cos inverse of 4 divided by 9, that is 63.61. I have verified it. 63.61 degrees. You can find either the Z in this way or the angle Z in the rule of triangles way. Okay. Now coming to our final step of finding OE. This is the side. Okay. Now how do we find angle side OE? OE is found. either by Pythagoras theorem. What is this Pythagoras theorem states? Square of the hypotenuse is equal to square of other two sides. So taking hypotenuse as 9, if you square the other side, which is 4 square, and then remains our OE. Okay, so we have to find this OE, which is labeled as so if you bring 4 square to the left hand side, so it will be 9 square minus 4 square, that is equal to E. So that will be 81 minus 16, that is equal to 65, and OE is equal to, if you take the square root on both the sides, this and this will get cancelled, root and the square, so what remains is only OE, and the square of 65, that will be equal to 8.06. Even here you have two options. You know the angle, one of the angles. So one of the angles, for example, if you are using this angle, which we know as 26.39. So what you have to do is cos, this is the adjacent side for O, isn't it? X is the adjacent side. So OE is the adjacent side. So angle O, cos O is nothing but this x divided by the hypotenuse. If we are using this angle, that is 63.61, which we have already found, then what will OE be? Opposite side. So sine z is equal to OE by hypotenuse. You can find either that way, or you can simply use Pythagoras theorem. This is, or you can yeah, you can use tan also. So anything is okay. You can find last OE side in multiple ways. Pythagoras is very simple. Yeah, so I think I have covered 5 problems in angles. If you want me to solve some more problems, you can write it in a comment, or if you're having any doubts among these 5 problems, you can still mention it in the comment. I will surely get into any of your queries. You can also Gmail me in the email I have provided in the comment below. Yeah, yeah, that's all for now. We'll be meeting you in the next video. Thank you. Have a good day. Have fun learning.